Welcome to this video, and in this video I just want to have a quick look at what a planetary nebula is. So planetary nebulas are probably some of the most exciting and interesting objects in the universe. They've got fantastic colours, some interesting shapes and structures, but what actually are they? Well, the first thing to point out, despite their name, is they're nothing to do with planets. So they're called planetary nebulas due to the way they were first discovered and what they were thought to represent, really. But they are to do with stars. They're much larger objects than planets, and it's purely down to historical context, really, why they're still called that. But they're to do with stars, not planets. So towards the end of a red giant's life, it begins to lose some of its outer layers. So they begin to be lost into space. And that is what then begins to form this planetary nebula. And it's towards the end part of the red giant phase, between the red giant phase and the white dwarf phase of a normal sun-like star. So the sun is going to go through this process. And it's typical of stars of a similar sort of size. Now, this is an image taken of a red giant that is at the end of its life. It's about to transition and it's losing a lot of mass. So this particular red giant is a variable star, so it's varying in output. It'll be pulsating. The stars are actually getting bigger and getting smaller, and that's what relates to some of the change in the brightness. But during that process, they do lose a lot of their material. So a red giant has, or when it gets to this part of its life, it's lost a lot of its, or will lose a lot of its mass. And when it gets to the final part, it will be a lot less massive than it was at the very start. So they lose a considerable amount of mass during this process. Now, during this process, you have the stellar winds from the actual central star, and it begins to remove these outer layers. So it's this wind that is actually removing these layers, and you're losing a lot of the mass from that. So it starts to begin to form this kind of envelope around the star, which will begin to form the actual planetary nebula. Now, during that process, the central star at the center is kind of exposed. It's very hot. So if you think about the center part of the star, the core of the star is the hottest part. That's where the fusion is happening. That's where the majority of the heat is, or the energy. So if you start to remove those outer layers, you can start to begin to see a very hot center. And these central stars are actually some of the hottest stars in the universe. These are the hottest of all stars. Even the most largest stars that we have are of the same sort of temperature, but they're very small. So it's actually a very small star at the center, because the rest of the material's kind of been has left the rest of the star. Now, the reason why you get all of these wonderful colours in that from these planetary nebulae is because you have this really hot central star, which then heats up the surrounding material and gas that is in this nebula. It then actually emits at its own wavelength. So it gives its own colour off because it's heated by this very hot central star. And you get a whole range of different colours, structures, and they're wonderful to look at. Now, in time, that planetary nebula will actually dissipate. So all that material, the envelope around it, is going to dissipate and disappear, and you'll be left with a very hot, small white dwarf star at the center. So these white dwarfs are essentially the central core of these red giant stars. The rest of the material has been lost into space. So what's left behind is actually not very big, and there's not a lot of mass there, but it's very compact and very dense. It's about the size of a terrestrial planet. So think about the size of Earth. That's the sort of size you'd expect for a white dwarf. But they're very, very hot. So again, you're talking hundreds of thousands of degrees, really, surface temperature for these stars, but they're just very, very small. And if we can remember the HR diagram, we have the white dwarfs that sit down at the bottom. So it's a little group of stars that are extremely hot, but because they're very small, they're actually not very bright because their surface area is very small. But in time, these white dwarf stars, they'll cool down and they will move towards the right-hand side, the lower right of the HR diagram, until they basically become not visible anymore because they won't be emitting any more light. But the reason for that is they're not generating any energy. It's just the leftover energy from when the star was actually creating energy due to fusion. So in time, these white dwarf stars will just disappear. Not necessarily disappear, but we won't be able to see them because they've become so dim. So thank you for watching.